So as I told, two locks are there, exclusive lock and shared lock. Okay, if you want to perform write operation, then you will go for exclusive lock. If you want to perform read operation, then you will go for shared lock. And otherwise here they have given exclusive mode and shared mode. And we have seen about lock compatibility matrix. For example, if two transactions want to perform a read operation on the same data item, it is possible. So here you see, yes, yes. If two persons are trying to get the S lock, and then it is possible. True, it is given here in the matrix as a true. So it is possible. But all other combination, it is not possible. All other combination, it is not possible. If one person is holding S lock on the particular data item, and if another person need the S lock or X lock, then it is not possible. Okay. So wherever we are having a false, it means simultaneously two person cannot do these activities. Only at a time you can able to read data that can be done by more than one person. But more than one person cannot able to perform read and write operation simultaneously. So that is log compatibility matrix. And we have seen one example and transaction. So before accessing any data item, first you have to get the log for that particular data item. So here they are going to read A value and they are going to read the B value and they are going to find sum of A and B. So before trying to access the value of A, that is before reading the value of A, first you have to get the log for the data item A. For each data item, you have to get the log. For example, two data item you are going to read from the database, you have to get two different log for each data item. And if you are going to do reading of only one data item, then you have to get only one log. Okay. And since here we are going to perform read operation, so S log is needed. So log S on the data item A. And then you are performing a read operation. After performing read operation, you can unlock the log. So unlock on the data item A, so that data item can be accessed by other transactions. So each transaction, if it wants to use any data item, it has to get the log, then it has to use that particular data item, then it can unlock it. It can unlock it. Okay. And similarly, it needs a B data item, so it is asking a log S on B. And then it is performing read operation for the data item B, and then it is unlocking it. Then it is displaying the value. And the problem with the two-phase locking or any locking protocol is a deadlock. For example, if there are two persons, one person is having a lock on one data item, other person is having a lock on another data item. But that data item is needed by other people. So in that case, both the person cannot able to complete their task. They have to wait for an infinite number of time, infinitely. So that kind of situation is known as a deadlock. So each transaction holding some lock and it is waiting for another lock. If that is the case, then the system is in a deadlock. Okay. So in the case of log-based protocol, there is a chance of a deadlock. How to if there is a chance of deadlock and there is a chance of starvation also. So what do you mean by starvation? If there is a deadlock, then how can you come out from the deadlock? Either one of the transactions have to be rolled back. So if the same transaction has been rolled back for a several time, if the same transaction is rolled back for the several time, then that particular transaction will be in a starvation. That is, just to wait for a longer period of time. Okay. So how can you manage this? How can you manage this kind of thing? You can go for using the concurrency control manager. So concurrency control techniques you can use so that you can allow more than one transaction to run concurrently. So as I told, two-phase locking protocol, there are two phases are there, phase 1, phase 2. Phase 1 is a growing phase, phase 2 is a shrinking phase. In phase 1, what you can do, transaction can obtain the locks on the data item and it cannot release the lock. And in the case of shrinking phase, the transaction can release a lock and the transaction cannot obtain the lock for the data item. Okay. So this protocol assures the serializability. As I told, two-phase locking protocol, if you are going to use, there is a chance of a deadlock. So how to minimize the deadlock and how to overcome from the deadlock now? You can go for a modified version of a two-phase locking protocol. There are two protocols are there, modified version of two-phase locking. First one is a strict two-phase locking protocol. And here, what it is doing, it hold all its exclusive lock till it commits the transaction. All the transaction hold all the exclusive lock till it does the commit operation. That is in the case of a strict two-phase locking. And the second modified one is rigorous two-phase locking protocol. In this case, all the transaction hold all kind of locks till it commits. So strict two-phase locking protocol and rigorous two-phase locking protocol are the modified version of a two-phase locking protocol. And we have seen about lock conversion. So what do you mean by lock conversion? In the case of two-phase locking protocol, in the phase 1, you are going to obtain the lock and you are not going to release the lock. Okay, in the case of phase 1. So one more thing you can do, you can upgrade the locks. For example, in the phase 1, already you are having S lock on a particular data item. Then it can be upgraded to lock X. You can get exclusive lock. Already you are having a shared lock on a particular data item. Now if you want to change that, then you can go for upgrading it to a exclusive lock. That is a lock upgradation. And similarly in the case of phase 2, second phase. So in the second phase you can release the locks, but you cannot obtain any new locks. And if whenever you are trying to release a lock, what you can do now, you can do the downgrade. For example, already you are having exclusive lock on a particular data item. That can be downgraded to shared lock. That is possible. That kind of thing is known as a lock conversion. And we have seen about the routine which is used for performing read operation and write operation. And how the concurrency control techniques are implemented now by using lock manager. Lock manager is responsible for providing concurrency control. So what the lock manager is doing? Lock manager is maintaining a lock table. Lock manager is maintaining a lock table. In that lock table, they will maintain the information about what are the data items are there, what are the transaction that is holding lock on that particular data item, who are the other transaction which is waiting to get the lock on that particular data item. Okay, and that is specified in the lock table. So the lock table structure will be like this. Here you see I7, I23, all these things are a data item. The rectangle boxes specifies the data items. Okay, and here you see squares are there now. That square specifies the transaction T1, T2, T8, T23. All these things are the transaction. T means transaction, I means data item. Okay, and for example, the dark black square is there now, filled square. That means that T23 transaction is holding the lock on the data item I7. And similarly here, T1 and T8 are holding the lock on the data item I23. And T2 is waiting for the lock. T2 is waiting for the lock on the data item I23. Okay. So in the lock table only, the lock manager maintain all the information. What all the data items are there? Here they'll be using the hashed hash structure, hash table. Okay, what are the data items are there? What are the transaction which is holding a lock on that particular data item? Who are all the transaction that is waiting for it? Everything is noted here. So today class we are going to see about two protocol. One is in today class we are going to see about two protocol. One is an graph based protocol, other one is an timestamp based protocol. So tree protocol, if they are asking you to explain a graph based protocol or tree protocol, you can explain the same. So tree protocol is a kind of a graph based protocol only. Tree protocol is a kind of a graph based protocol. So in today's class, we are going to see about graph based protocol, or otherwise we can name that as a tree protocol. And the second one which we are going to see is timestamp based protocol. Two protocol we are going to see in the today class. Okay. So what is a graph based protocol? Graph based protocol is an alternative of a two-phase locking protocol. Graph based protocol is an alternative of a graph based protocol is an alternative for the two-phase locking protocol. Here, in the graph based protocol, it imposes partial ordering. The order in which you can get the lock on the data item that they will be specified. Okay. So, for example, there are n number of data items are there. So, that is specified here. D1, D2 up to DH. So, H number of data items are available here. Okay. So, here you will be specifying the order also. For example, if there is an order like this, if Ti arrow dj, it means that you can get the lock on the data item dj only if you get the lock on the data item di. Okay, I'm trying to get the marker. That marker is not available. Okay, so in the case of graph-based protocol, we are going to have set of data item. For example, the data items are D1, D2 up to DH. So, and we will be specifying the order in which you can get the locks. Okay, for example, DI, DJ, DI arrow DJ. It means that if you are already having a lock on the data item DI, then only you can get the lock on the data item DJ. Okay, so DI before accessing DJ. First you should get the lock on DI, then only you can get the lock on DJ. Okay, and this can be specified by directed acyclic graph, and the other name of directed acyclic graph is database graph. Okay, so as I told, tree protocol is a kind of a graph protocol. So it is a tree protocol. Here you see it is a directed acyclic graph. Directed acyclic graph. Tree protocol. This structure, if you are seeing, it is an directed one and it is an acyclic. Okay. Here you see what it means. You can get the lock on any data item. For example, I want to get the lock on the data item B. Now I can able to get that as an initial stage. So first, if I want to get the lock on the data item D, now I can able to get. So initially, you can get the lock on any data item. There won't be any issues. Okay. And if you are trying to get the next lock, second lock, if you are going to get, consider that I am having a lock on the data item B. So first request which I have given us, I want a lock on the data item B. Okay. First request for a data item can be of anything. So let us consider that I have requested the lock on the data item B. Okay. Now, afterwards, if I am trying to get the lock on the data item D, it is possible. Why means already I am having a lock on the data item B, so I can able to get it. And if I am trying to get the lock on I, it is not possible. Why means I am not having the lock on the data item E. If I have the lock on the data item E, then only I can get the lock on the data item I. Okay. I need the marker. Okay. So let us consider that I am having a lock on B. By keeping that, I can get the lock on the data item D, E, F. Okay. But without getting lock on data item E, I cannot get the lock on the data item I. Similarly, my initial lock is on B. If I am trying to get the lock on A, it is not possible. I cannot able to get the lock on A. Similarly, if I am trying to get the lock on C, it is also not possible. Okay. If I in this tree structure, if you are trying to get the lock on any data item, first you should get the lock on the parent. If you already have the lock on the parent data item, then you can get the lock on the child data item. Okay. So other thing that you have to consider in the tree protocol is only exclusive locks are allowed. In the tree protocol, only exclusive locks are allowed. And the first lock by any transaction Ti may be on any data item. Subsequently, a data Q can be locked by Ti only if the parent of Q is currently locked by Ti. Data item may be unlocked at any point of time. So these three things you have to consider. So only exclusive locks are allowed. Only exclusive locks are allowed. Okay. And the data item can be unlocked at any time. You can unlock the data item at any time. And the first lock you can get on any transaction, any data item. The first lock can be obtained on any data item. Here A, B, C, D, E, F, G, all these things are the data item. So the first lock, first data item or the first lock you can get on any data item. After that, whenever you are trying to get the lock on a particular data item Q, it is possible only if you are having a lock on the parent of Q. Okay. So is it clear?
Yes, ma'am.
Only one person is responding. Soumya, now only you are coming. Okay. So this tree protocol ensures a conflict serializability and it is a free from the deadlock. It is a free from the deadlock. So if you are using the tree protocol and there is a no chance of occurrence of a deadlock. So the advantages of using graph-based protocol or the tree protocol is it gives a shorter waiting time and it increases the concurrency. Advantages are shorter waited time and it increases the concurrency. And the protocol is deadlock free. So there won't be any chance of a deadlock. So no rollback is required. Okay. These are the advantages if you are using the tree protocol. So tree protocol, three major advantage: shorter waiting time, you can increase the concurrency, and it is free from the deadlock. And the disadvantages: increased locking overhead, and sometimes there is an additional waiting time for some time. And In some cases, there will be decrease in the concurrency. Okay. And till now we have seen about the graph-based protocol, and tree protocol is a kind of a graph-based protocol. So if they are in the exam, if they are asking graph-based protocol or a tree protocol, the concept is same. Tree protocol is a kind of a graph-based protocol. Okay. Here you will be setting the partial ordering of a data item. Partial ordering of a data item you will be specifying. Okay. So partial ordering of a data item you will be specifying. In that order, you can get the lock on the data item. Okay. So whenever you are trying to use a tree protocol, you have to consider three things. Tree protocol, in the tree protocol, only exclusive locks are allowed, and you can unlock the data item at any point of time. And at the first lock, you can get on any data item. And subsequently, if you are trying to get the lock on a particular data item Q, then it is mandatory that its parent lock you should keep. Then only you can get the lock of the child data item. Okay. So these 3 points you have to consider in the case of a tree protocol. And next we are going to see about the timestamp protocol. Timestamp based protocol. So in the case of timestamp based protocol, we will be having the transaction with the name of TI, TJ like that, and we are going to use the term TS. TS means timestamp. TS means timestamp. So what is a timestamp now? Whenever any transaction enter into a system, that time will be given as a timestamp of that particular transaction. For example, the transaction TI enter at 1 o'clock. Then what is the timestamp of that particular transaction? Now it is 1 p.m. Okay. And if there is another transaction which enter into the system at 1:05 p.m. then the timestamp of that particular transaction is 1:05 p.m. Okay. The time at which the transaction enter into a system is specified as a timestamp of that particular data item, of that particular transaction. Okay. So each transaction will have its own timestamp. Okay. And another thing which you are dealing here is a data item. Each data item also has two timestamp. One is a write timestamp, other one is a read timestamp. Okay. So what is a write timestamp? That is specified by here, write hyphen timestamp of Q. So it is the largest timestamp of any transaction that executed write Q successfully. For example, T1 transaction executed write on Q. Then what is the timestamp of T1? That will be the write timestamp of Q. Write timestamp of Q. Similarly, if there is any transaction which perform read on a particular data item, okay, so that particular transaction timestamp will be the timestamp of a R timestamp. Okay. Sai Vardhan, at what time you will come to class? So in the case of timestamp based protocol, we are going to deal with the transaction and we are going to deal with the data item. So for each transaction, you are going to have the timestamp TS of TI, TS of T1, TS of T2, TS of TJ like that. What is the TS? It is a timestamp. So how you can get the timestamp now? Whenever any transaction enter into a system, at what time it is entering into a system, that will be specified as a timestamp of that particular transaction. Okay. And similarly, for each data item which is present in a system, each data item which is present in the database, that for each data item, it is going to have two timestamp. One is a write timestamp, other one is a read timestamp. So write timestamp of Q, read timestamp of Q. What is how will you take this value now? Write timestamp of Q, it is a largest timestamp of any transaction which is trying to perform the write Q operation. Similarly, R timestamp of Q, it is the largest timestamp of any transaction that executed read Q. Okay. So is there any doubt with this?
No, ma'am.
Only Sai Diti is responding. Others?
No doubt, sir.
Thank you. Okay. So now in the case of timestamp based protocol, whenever any transaction trying to perform read operation, whether the read operation will be successful or not, that we are going to see. Similarly, in this timestamp based protocol, if any transaction is trying to perform write operation, whether the write operation will be performed successfully or not, that we are going to see. So there are some conditions that should be satisfied, then only that particular operations will be carried out. First, we are going to perform, we are going to see whenever any transaction Ti that perform a read operation, whether that read operation will be successful or not, that we are going to see. Okay. Understand? There is a one transaction, it is going to perform read operation and write operation on a particular data item. Whether the read and write operation is going to be completed successfully or not, that we are going to see. Okay. For example, the transaction Ti issues a read Q. So Ti want to perform read operation on the data item Q. Okay. So you have to check whether the timestamp of Ti is less than or equal to write timestamp of Q. If that is the case, then the read operation is rejected and the Ti will be rolled back. And the Ti will be rolled back. You have to keep in mind this condition. You have to keep in mind this condition. Okay. If the timestamp of that particular transaction is less than the write timestamp of Q, write timestamp of Q, then that read operations will be rejected and that transaction have to be rolled back. Otherwise, the read operation will be executed successfully. Okay. And this is in the case of read. When second operation which any transaction is performing is a write operation. Whenever any transaction is performing the write operation, whenever any transaction is performing a write operation, then it has to check this condition. Okay. So if timestamp of Ti is less than or timestamp of Q or timestamp of Q, and if timestamp of Ti is less than write timestamp of Q, if these two conditions are true, then the write operation will be rejected and the particular transaction Ti should be rolled back. In all other cases, the write operation will be executed and the write timestamp of Q is set to timestamp of Ti. So you have to keep these conditions in your mind. So again I'm saying, there is a transaction, it is the transaction means either it is going to perform read operation or write operation. If a transaction wants to perform read operation, that read operation will be successful when if the timestamp of Ti is greater than the timestamp of write timestamp of Q. In that case only read operation is executed successfully. So if the timestamp of Ti is less than or equal to write timestamp of Q, in that case read operation will be rejected. And if a transaction wants to perform a write on a particular data item Q, then it has to check that timestamp of that particular transaction should be less than reads timestamp of Q as well as write timestamp of Q. If that is the case, in that case, write operation is rejected. Otherwise, write operations will be performed. So no other way how to keep this condition in mind. So when it will be rejected, read operation will be rejected when the timestamp of a transaction is less than or equal to write timestamp. Okay. And here write operation will be rejected when timestamp of TA is less than R timestamp as well as write timestamp of Q. It will be rejected. Otherwise, it will be performed. These two things you have to keep in mind. And this timestamp ordering protocol guarantees serializability. It guarantees serializability. And it is a free from the deadlock. It is a free from the deadlock. But in some cases, the schedule may not be the cascade free and it may not be the recoverable schedule. In some cases, the schedule may not be the cascade free and may not be the recoverable schedule. But it ensures the serializability and it is a free from the deadlock. And timestamp protocol is over. It is simple only. The major thing is you have to keep in mind this condition. If these two conditions are satisfied, then that operation rejected. Otherwise, the operation will be successful. That point you have to keep in mind. So graph-based protocol and time-based protocol is, that's it. And we will go for one quiz question. Is there any doubt with the timestamp based protocol?
No, ma'am.
No, ma'am.
Okay. So what we have seen in today's class, we have seen about a graph-based protocol. Graph-based protocol is an alternative of a two-phase locking protocol. Here it has a partial ordering. That is the order in which you can acquire the lock on the data item. For example, memory, hard disk, printer, like that. So hard disk, memory, both are same. First you can take memory and then printer. Which one you need first? Which object you need first? Whenever you are working in a system. Memory. Yes. Yes. So they will be specifying the order in which, so you consider these two are the data item. Memory is a one data item, hard disk is another data item. So they will put all this data item in order. First, if you want to get the lock, first lock you should get on memory. Then only you can get the lock on the printer. Okay, like that they will put an order. The order in which you can get the lock on the data item, that they will be specifying in the case of a graph-based protocol. Okay, so that only shown here. DI arrow DJ. That means if you want to get the lock on the data item DJ, first you should get the lock on the DI. Then only you can get the lock on DJ. Similarly, directly you cannot go and get the lock on printer. First you have to get the lock on memory, then only you can get the lock on printer. So that is an ordering, partial ordering. So tree protocol is a kind of a graph-based protocol. So your tree protocol looks like this, and it is a tree-like structure only. Here we have node. Each node specifies the data item. Each node specifies the data item. This edges specifies the order in which you can get the lock. If I have the lock on A, then I can get the lock on B and C. If I am having a lock on B, then I can get the lock on D, E, F. Okay. So if I have the lock on B, if I am trying to get the lock on J, it is not possible. Who is the parent of J? Who is the parent of J?
H, ma'am.
H. First I should get the lock on H, then only I can get the lock on J. Okay, so that only specified in the tree protocol. So 3 points are here. Only exclusive locks are allowed in the tree protocol. You can release a lock at any point of time, and fast lock you can get on any data item. It is not mandatory that you have to get lock only on A. Initially, if I want to get the lock on D, that is also possible. But if I get the lock on D at the initial stage, then I can get the lock on G, H, J. Only these 3 items I can use. These 4 items, D, G, H, J. I cannot get the lock on other items. In this item, A, B, E, F, C, I. For these items, I cannot able to get. Okay. So the first lock you can get on any data item, but subsequently, whenever you are trying to get the lock on any data item, you should keep the lock on a parent data on its parent data item. Then only you can get the lock on a child data item. That is tree protocol, and it is a free from the deadlock, and it ensures a shorter waiting time, and it increases concurrency. It is a free from deadlock. And the next is a timestamp based protocol. So whatever the timestamp it is maintaining, for each transaction it maintains the timestamp. The time at which the transaction enter into a system, that becomes the timestamp of that particular transaction. And for each data item, Q, it is maintaining 2 timestamp. One is a read timestamp, other one is a write timestamp. What is a write timestamp now? It is the largest timestamp of any transaction that executed write Q successfully. Similarly, R timestamp of Q. It is the largest timestamp of any data item that executed read Q successfully. So any transaction, if it wants to perform read operation, and that is possible, that read operation is successful only when if this condition is false. If this condition is false, then only the read operation is successful. If this condition is true, read operation is rejected, and your transaction have to be rolled back. Okay, so what is that condition? Timestamp of Ti should be less than or equal to write timestamp of Q. If this condition is false, then it can perform read operation. If this condition is true, read operation will be rejected and your transaction should be rolled back. And when any transaction wants to perform a write operation, then you have to go for checking these 2 conditions. So if these 2 conditions are false, then only you can perform write operation. If these 2 conditions are true, then you cannot perform the write operation. Your transaction have to be rolled back. Okay. And here timestamp ordering protocol ensures serializability, and this also free from the deadlock. And but in some cases, the schedule which you are preparing, that may not be the cascade free, and that schedule may not be the recoverable.